Is it gonna work? Oh man. Hey, it does work. Hey. Now does the audio go through? Hey, it does work. Hey. Okay, where is the URL? All right, internet people. Welcome to the pain train. So, if you're new to the show, my name's Sean, and I host the Advent of Computing podcast, which is a show all about the history of the computer. And mostly it's digital, but there's also a bunch that's not digital. Turns out that computers and computer-like stuff have been around for a really long time, like at least going on 100 years, more if you count, like, say, some of the automatic looms and whatnot. But during my research for the show, I run into a lot of weird stuff. And one of those are what I'm scanning right now. So these are what's known as edge-notched cards, which they're pretty neat little things. So they're just a piece of cardstock, kind of like a punched card, but instead of being punched like a punch card, they have holes and notches on the edges. They're not meant to hold binary data. It's instead meant to encode indexing. So think of like a cardstock database, kind of. How they work is that, so the code is encoded in these notches. A 0 would be just a hole, but a notch is a 1. So then if I grab a prop, normally when you use edge notch cards, you have something like a knitting needle. In this case, a toothpick, since these are relatively small. So if it's inserted through a hole, like for instance, for the hooked bill on this card, that would stay on the needle, so that won't slide off. But in a notch, the card slides off the peg. So by doing a simple operation with a toothpick or usually a knitting needle, you can filter and sort and do different logical operations on a stack of cardstock. So this particular set is, as is probably apparent, a set of cards that make up a bird book. This is the Eastern Birds of the Americas deck. So it's a weird technology. I first found... Ooh, that was a bad scan. I first found out about these when I was doing research for an episode I did on punch cards. That was episode 1 of the cast, really episode 2, since there is a secret episode that I will never release that's awful. But a little after recording episode 1, I found out about edge-notched cards as a similar technology to punch cards. It's similar, but not the same at all, really. Just happens that there's some holes on cardstock. But it took me down a rabbit hole, so I made a mini episode on the technology. It's, I think, episode 6.5 or something. It's called Edge Notched. That gives like the basic rundown of these cards, but here's the problem. Like I was saying, the history of computers is really, really long. Like, you'd be surprised. Oh, come on. Sorry, fiddling with this thing so it actually detects right. So the history of the computer is really long, and this is a perfect example. Edge-notch cards were invented and reinvented multiple times. The earliest examples show up sometime around the 1920s. It gets a little fuzzy. There may have been examples that are contemporary to the 1890 invention of the punch card. But the sourcing, it turns out, is awful around this technology. The last book written on edge-notch cards, or the last close to academic text, was published, 2 editions. Final one came out in like 1964, I think. The book's called Punched Cards, Their Applications to Science and Industry. And despite the name, only about half of it's about punched cards. Most of it is about these suckers. But what's fascinating about these cards, besides, they're old and there's bad sourcing around them, is they actually show up a lot of places. So this example that I'm scanning right now, these are weird because these are pre-printed. So how this works is you go to the store or the bookstore or wherever, and I don't know if you can see it, but this is a stack of these cards. So you buy a stack. And then if you're out birding, you can filter through and be like, oh, well, I'm looking for a bird that has a rounded tail or a square tail or whatever, and then use this as a diagnostic tool to find what bird you're looking at. But this specific set is interesting because it's the only pre-printed set of cards I've ever been able to find. By and large, these were sold as blank note cards. They're used primarily in the sciences and research and in accounting, anytime you have a lot of data. And one of the people who use these cards is a man by the name of Douglas Engelbart. So if that name doesn't ring any bells, Doug Engelbart is kind of the person who designed the idea of the modern user interface, and also in doing so created things like the mouse, hypertext. There's a lot of things that are attributed to Engelbart and his lab SRI. Oh man, I'm forgetting the date. Oh no. Believe 1961, but it might have been 1970. I'm forgetting the date, but before home computers or anything graphical was mainstream, Engelbart did this event called the Mother of All Demos. It's called that now. At the time, I think it was just called a demonstration of the online system or something. But he showed all of his technology. He showed a graphical user interface with a mouse, windows, icons, pointers. His mouse is resoundingly similar to modern day mice. And he shows it all off way before anyone else is doing anything similar. The core of the Mother of All Demos comes back to this report he wrote called Augmenting Human Intellect. It's kind of one of the core sources for guiding the development of user interfaces. The whole text was about, people aren't able to work at maximum capacity because there's so much data. And we can't really upgrade people, but we can make tools to help make people more efficient. And in Engelbart's approximation, the tool to do that was a very, very fancy computer and some very fancy software. And that thinking at least, led to the creation of the first graphical user interface and the mother of all demos. So the reason I bring up Doug Engelbart and all of this future fancy stuff is because buried away inside of Augmenting Human Intellect, it's in an appendix, he talks about his research methods and how he conducted his research for the actual paper. Since, he wasn't just talking I think we need computers. He actually did a lot of research on the modern state of computing and did something kind of like brain charts and whatnot for determining what could be done with existing technology and what would be most feasible. In one of the appendices, he mentions that in designing his interface, he kept notes on a deck of edge-notched cards, which that's kind of a big deal, since the important part here is these aren't very well documented. There are very few sets of scans of edge-notched cards on the internet, and there's even less information about the technology in general. But it shows up here in a very, very important place. What makes things more interesting is when Engelbart was talking in that paper about edge-notched cards, he talks about them like a database. And specifically he says that, and this isn't going to be the quote, this is paraphrasing, but he says that he kept his notes on a stack of edge-notched cards, and you could improve his filing system by putting reference numbers on the little edges here, and then constructing links between cards. So that's a big deal because he's talking about using cardstock to make a hyperlinked database, which, you know, if you're familiar with the internet, that's a very close description to the interface side of the internet, where we have data that's linked together through hyperlinks. And Engelbart's describing how he was able to do that using cardstock in like 1950s. So that makes this technology a very, very big deal that, you know, there's no scholarly work on. At least there hasn't been in decades. So ever since I read that, I've been kind of on a hunt to try to find more information about edge-notched cards and find any edge-notched cards. Because like I was saying, it's really hard to find sets of these digitized anywhere. And it's also really hard just to find sets of these at all. In my work, well, I guess it's not work. In my adventure, I found, I want to say, I got some new scans from a university last week, so I think I have 6 sets of edge-notched cards, and that's after about a year and a half of searching. These are, I celebrate every time I find a single image of these that's new. But that should be kind of a tragedy, right? Because this is a technology that influenced the development of what would eventually become the internet. It's kind of in an abstract way, right? Since Engelbart is saying in Augmenting Human Intellect that he used these, and he doesn't say it's his inspiration, but he says that before NLS, he had a linked database of edge-notched cards that he used for notes and research. The other reason that's a big deal, just if you don't know 100% of the context, is so the idea of hyperlinks is actually pretty old. It was first written about in 1945 in the article As We May Think by Vannevar Bush, where he describes this thought machine. It's a thought machine since it doesn't exist, called the Memex, which stored data on microfilm in a big desk, and each page you could make a trail of thoughts linking multiple pages. So once again, it's a description of something similar to the idea of data and linking that we use on the internet. But the thing with Memex is it was a thought experiment. It was never built, and it just doesn't exist. You could call it vaporware, but As We May Think, Vannevar Bush never says like, oh, we're going to make this. He's just like, well, wouldn't this be interesting? This is one way that you could model data after how humans think. And then by doing so, you can do some cool stuff. You can augment what a human can do. So then fast forward a few years, and we have Engelbart saying, oh yeah, I'm doing the same thing that a Memex could do, theoretically, but using cardstock. And then fast forward a few more years, and Engelbart demonstrates the technology on a computer. So first implementation of a hyperlink is on these suckers. And then the first digital implementation of a hyperlink is highly influenced by these cards. So really, this technology is a very big deal that just no one talks about. And there's like I was saying before, there's a few sources online and there's a few books. The sources online are all pretty sparse. I think there was an article on Hackaday about these a while back. I think the Obsolanium or some website about obsolete media has a page on these cards. And there's a Wikipedia page, of course, but there's not that much on it. It's one of those Wikipedia pages that I think is just a placeholder because there's like a source and an image that mentions these. So this is underserved. Once these are scanned, I'm probably going to put them up on the archive, I think, since, this is part of our heritage that needs to be better known. But then, so going back to the sourcing, like I mentioned, there's also some books that talk about edge notch cards. The most recent is probably 1964 or something, because what you have to understand is these were used in like very, very unsexy applications for decades. Like I was saying, they're used in research. People like Doug Engelbart use them for notes. He used them extensively for bibliographic sources and for kind of like idea mapping stuff when he was designing NLS. But they were also used for wonderful things like accounting, which no one actually cares about, and no one really cares about like, oh, what methods did accountants in the 1940s use to track data and do risk analysis? No one cares about that. But the net result is there's a lot of really dry writing about these edge notch cards in like the 40s and 50s, and there's some more comprehensive like state of the field stuff in the 1960s. Books have titles like Your Guide to Personal Indexing Using Edge Notched Media. So it's not the most riveting stuff, and most of the books are out of print, obviously. No, not most. All of them are, because no one wants a book talking about the application of punch cards to science and industry in 2020. Well, except people like me and people who listen to the show. So, like I was saying, profound lack of scholarship on these. So, basically that's the outline of what I knew about edge notch cards about a year ago. And like I was saying, that sent me on this bizarre quest to find as many of these things as I can. Now, been a little successful. One of the big successes I've had is I actually got access to Doug Engelbart's notes on edge notch cards. So that was an ordeal in itself, because I don't know how many listeners, oh dear listeners, have dealt with archives. The state of the archive system in anywhere is bizarre. So in America, on the national level, there's things like the Library of Congress and the National Archives. And those are wonderful resources. They're very, very important to public discourse, to research in general, especially history research, and just for like the well-being of academics. But they're not the friendliest things to use. So at one point, I was trying to find if there was anything about edge notch cards in the Library of Congress. There's scant mentions. National Archives, also, I have a few leads there, but the problem is there's scanning fees involved with getting a lot of things processed, and that varies from archive to archive, if it's private or public. Usually the fees, it's free to get X number of scans made, but once you hit a certain point, you have to start paying an archivist, because as you can tell from me fiddling around here, this is a very arduous process to do. So if you can find cards, then getting them scanned isn't free all the time. And I believe I found a file box that may have cards in the National Archives, but that's going to be a bit of a problem, especially right now because of, the virus and everything. But the other problem is finding aids. So when you're looking through, when you're looking through archives, you don't have that much information about what you're looking at, which is awful, and I hate it. Instead, so you don't get like a comprehensive inventory of what's in a collection. You get these things called finding aids, which are the worst thing on the planet. Basically, it's a list of every item, every lot, usually like a file folder for this kind of stuff, that's in some group, some collection. They're usually ID'd by something. Places like Stanford use a Cinchen number. I've seen different things like serial numbers. Once again, it depends on the archive, but by and large, you get a list that will have the number of the item, and then it'll say one sentence maybe about what the item is. So you could get something that's like item number 587, a stack of notes relating to like survey XYZ. Or you get item number 89 ? Cards. Or more often, something like notes or miscellaneous files. As you can see, it's awful. And what makes that particularly difficult for edge-notched cards and for finding these dudes is, well, in the words of a kind of terse worker at the National Archives that emailed me back, we don't index information by media type. And so, of course, they do like audio and paper. But if you ask for edge-notched cards and you're like, hey, I'm looking through this collection, I see this thing, are these edge-notched cards? A lot of times, archivists are busy, management's busy. Actual like physical materials will be stored in an off-site area, so they might not ever go to that building, or might very rarely. So oftentimes, if you're like, hey, can you check this? They're like, no, I cannot check this. You can pay for someone to do it. So that's a struggle. But using some clues and context, I was actually, like I alluded to earlier, able to track down Doug Engelbart's edge-notch cards. So they were, just quick history lesson, Engelbart's lab, his lab, ARC. It was affiliated with SRI, the Stanford Research Institute, which it's confusing. It's not technically part of Stanford, the university, but it's like a block away from Stanford, maybe 2 blocks. They're very close. They do stuff together. They're just not officially affiliated or whatever. I think it's probably a tax thing because that's how confusing things are. But they have an archive at Stanford. And luckily, the Engelbart family, I don't think it was Doug, I think it was his daughter Christina, donated a bunch of Doug's notes to the Stanford archive. And you can find the finding guide online, and it is awful. Like all finding guides, you get a sentence if you're lucky. And so I was emailing back and forth with an archivist over at Stanford about it, late 2019, I guess. Just trying to get some more information, emailing with Christina a little bit, Engelbart's daughter, trying to get some more information. And they confirmed that, yeah, there's probably cards in there. Christina Engelbart especially was like, oh yeah, I remember my dad using these cards. So if they're anywhere, they'd be in the collection. But the problem is the collection is like the Engelbart collection. It's probably a dozen file boxes, like, the big ones. It's a lot of paper. It's not something you can just be like, hey, can you go scan a dozen file boxes worth of material for me? Yeah, no problem. Just, go to an outbuilding and sit down for a few days and just scan everything. What could go wrong, right? But undeterred, the other option with archives and private collections is just to go there and do it yourself, which costs... It depends. There's a break-even point. Sometimes it costs less if it's, excuse me, if it's like this case, it ended up, I ran the numbers, and it cost less to just drive down to San Francisco. I don't live very far away from there. Rent a cheap hotel room, the cheapest one I can find near Stanford, and spend a couple days going through boxes and scanning stuff. So that didn't end up being a big problem. But what was frustrating is, once again, the finding guide. Finding guides are the worst thing ever invented by academics, and I swear they are made to be awful so that academics keep their jobs. So, I guess that's a hit against me, huh? We don't do any service for each other. But so looking through the finding guide, I found a section of lots that I believed could have edge-notched cards. And with how policy works at Stanford, you can check out, like 5 file boxes, or no, 5 ascension number lots a day. So I found, that's been damaged. This is why I'm scanning them. Handling them is dangerous. Anyway, I found about 10 boxes that I thought were like, well, if they're anywhere, they're going to be in here. So I booked the time, booked a hotel room, got time off work, drove down, and actually did the process of sitting in a room at Stanford, going through box after box of papers for 2 days. And luckily it bore fruit, and I was able to find, I think, all of the cards. There might be more, because it turns out that they weren't on the finding guide index, or at least not in any way that someone would have been able to tell. On the second day, when I was about halfway through my pile of pain, I ran into a filing box that had 2 smaller boxes inside it. And normally how it works is you have an ascension number, or at least in the Stanford archives, you have an ascension number that's like the big box that holds all the files. And I flubbed. I said that there are like a dozen in the Engelbart collection, but I think there's like 65. I'd have to look it up. There's a lot. It'll be untenable to search the entire thing on your own. Anyway, so each box has an ascension number, and then within the box, each file folder or container or whatever has its own ID within that ascension. So if you're looking at a single file, you might reference it as like, oh, it's ascension 583-M2 or whatever for media number 2. So, every folder, every box inside these larger ascension boxes has to have an ID. Well, turns out the box that had all of these edge-notched cards, a few thousand edge-notched cards that, once again, let me remind you, are integral to understanding the history of the development of the internet and modern computing, they don't have an ID number. They're just there in a box that, it's great. They're actually in punch card boxes, big IBM punch card boxes that just have the name Doug written on them in magic marker. And then inside, just the notes that assisted in the creation of the first graphical user interface. No big deal. So luckily I have all the deets now, so if I ever need to return, I can do that. And I've shared the deets with my contacts at Stanford, but it's very frustrating because this technology is kind of lost. And that example of having to write back and forth with archivists and everyone else involved and go down myself because it's too expensive to scan thousands and thousands of pages of paper, I think is kind of indicative of what's happened to this technology. It's something that existed and filled a very specific niche for a very long time. And then later on, it kind of just disappears. And that's a shame, since this is a really important technology, not just because of the development of the internet, but it tells a story that runs kind of parallel to the development of the computer. That's something that I run into in the on Advent of Computing on my podcast a lot, is that there's a conventional narrative, but the problem with conventional narratives is they're simple. And they kind of have to be, because if you get into every little detail, all the zigs and zags and parallel developments, then, man, that's going to be awful. You're going to be there all day. You're not going to understand what's going on. You're going to be scared. I know I'm scared approaching new topics because they're confusing. And a lot of people just won't get over that and just be like, oof, I don't want to learn about computers anymore. Please help. So a lot of what I try to do on the podcast is challenge that a little bit, because there's important things that go on behind the scenes that aren't known about or aren't documented. And these are a perfect example. So edge-notch cards, they show up sometime in the 1920s. Once again, in my research, the date's kind of murky. In my head, I said it as 1927 because there's a patent that looks roughly like these suckers that comes out in 1927, but it's kind of dubious if they were actually used back then. Anyway, so these suckers hit the scene, and they're used until, like, I think the latest source I found was a scant reference in a FOIA doc about a government crime database that the DOJ kept on edge-notch cards. Just a second. Got another stack. So these are used for a really long time. And like I was saying, they're just hidden away in really lame, unexciting niches. But what's really wild is they filled a very specific niche very well. People who used edge-notch cards, by and large, or at least in my research by and large, weren't using punch cards. And the reason for that is punch cards are cheap. It's just card stock. But you know what isn't cheap? The machines you use with punch cards. Problem is, a tabulator, a punch, a sorter, all that equipment really adds up. It's a big barrier to entry. It's kind of like buying a fancy new computer today. You could, buy a cheap laptop, or you could get a top-of-the-line server kind of system. Each of them has their place. You don't run a data center on a laptop, and most people who have a laptop probably don't have the money for a big server. And the same was true with data storage. This isn't traditionally what you'd call data storage, but it functions in a similar way. A lot of people, like accountants, like researchers, need a way to store data. But, very few of them actually had money for a tabulator. And the other complication here is that IBM hardware, you didn't buy it, you leased it. So to own a tabulator, you don't own it. You pay a recurring fee to IBM. That ain't cheap. That means that on top of, let's say you're an accounting firm, on top of paying rent on a building, paying taxes on everything, and then paying for all your employees, you also have to pay IBM to lease out hardware. That adds up real quick. So there were alternatives. One was you use a perpetual ledger or something that's just graph paper. That's awful. That works if you are an accounting firm for a small family or maybe a few hundred people. But once you hit a certain point, you just can't do it. It's exactly like it's the information problem. It's what Vannevar Bush was talking about in As We May Think. There's a certain point where there's just too much data for a person to process unaided. You get wrecked. So instead of getting wrecked, people went for alternatives. Punch cards were a great alternative, but they're expensive. So alternatively to the alternative, you get edge-notch cards. It costs card stock money, which is cheap, and then you get one of these, which I'm using a toothpick, but they had special needles that you use for sorting, usually called sort needles, inventively, and you're good. You can use just a hole punch. You can get specialized punches to do these, but you can use scissors, hole punch. It's a really ad hoc technology, since you know, it's a piece of paper with holes in it and you use a needle to sort through it. You can make these if you have enough time, or more often you can just buy these blank by the thousand. But here's the dig, and here's what makes this more important than just a cheaper alternative to punched cards. These weren't used for the same things as punched cards. And this is a little confusing, or at least it was for me at first. But here, actually, let me grab a punch card. I have one around. That's an IBM punch card, or actually, I think this is some generic punch card. Punch cards are great at storing digital data. You need a machine to use it. You can't use it in the field since, like, let's say you're out birding, you can't carry around a punch card tabulator with you. Those are very heavy and very delicate and expensive pieces of machinery. Even if you could carry around, you wouldn't want to. That's a recipe for a bad time. Compare that to this. These, you can kind of store digital data on them, and there's some cards, you can kind of see it here. These are a little different since they're not, this specific set isn't primarily data storage, it's for searching. But you can store numbers on them. And a lot of times people would put serial numbers on each card, just like an incrementing database ID, or you could encode like a year. But primarily, these were used for sorting and searching. So going back to the punch card, you can't sort this very easily unless you have a machine. Like, let's say you want to sort by like the first column here. Are you going to eyeball 1,000 punch cards? No. That would be just as slow as sorting by hand. And then also, once stuff's committed on here, it's not superhuman readable. A lot of times you'd print like an automatic punch would print the data in each column on this empty overpunch row, but still, like, you don't get any gains if you try to hand sort this. These, however, you can just sort. You just do it. You get your needle, you poke your needle through the proper entry hole, you lift, and then any card that has a notch falls out of the pack. Any card that has a hole stays in the pack. So by doing that, you can actually build up a really robust system. Like I was saying at the beginning, it's a database. It's a database that's just on cardstock instead of on a computer. So it's cheap, it functions like a database, and you can build up a robust system. But the other thing here is, once again, we're in this territory, where we're talking about the medium and what the medium lends itself to. And I'd make the argument, and I'm working on the argument, sourcing is frustrating because, there's no sourcing on edge-notched cards that's digitized, or at least very scant sourcing. But these lend themselves a lot better to something like hyperlinks or reference numbers than a punch card does. Because you can, in most systems I've seen, on the face here, someone will print a reference number and be like, oh, Nighthawk reference number R513 or whatever. And then you go to your reference holes and you search up that reference number, and then you get more information or something related. Oh, I did not scan this. Now I did scan this. You can do that with punch cards, but you can't do that it's not a trivial operation. The problem is you'd have to look through the whole deck. And these, you're still looking through the whole deck when you're searching, but you can do it a lot more simply. All right, detect the card. Anyway, so the media lends itself to a different type of operation than punched cards. Oh man, why is this card not wanting to be detected? Go. Go. Oh, the pains of modern technology. So like I was saying, these lend themselves to a different kind of data. The other important thing is, since you're not using a machine, it doesn't have to be machine readable. These are primarily done by hand. Later on, there's some evidence that one company made a digitizing machine for these, and there weren't really automatic sorts, but there was automatic punching stuff. That card just doesn't want to scan. Do it. Anyway, so these aren't meant for robots. As we can see, even modern computers don't want to read edge-notched cards. Man, trying to be sneaky and it doesn't work. But so these cards are a great example of, this is something you just can't really do with a punched card. The glaring part here is on the face. There's, human readable text, which you can put text on punch cards, but you can't put it very dense. You can put 80 characters. So, less than a tweet if we want to be 21st century with it. But you can also put images, since these are meant to be read by a person. It doesn't matter what you put on it. I'm deleting that photo because I had my indicator on there. So, like I was saying, you can put anything you want on here, as long as someone can look at it and understand it. You could put music lyrics, you could put pictures, you could put sheet music. I actually have a few examples I found where, actually, in Engelbart's notes, he has examples of newspaper clippings that are just pasted onto cards. These aren't going through a machine, so the clippings aren't going to get ripped off and gum up the machine. And you're just looking at it. So you can have whatever you want. And while that might not be the best for computers, it's really good for people and for smaller scale uses. Eventually, these die out, I think largely in part, once again, just like the beginning, there's no sourcing of note, but they start to die out once personal computers exist, which, it makes intuitive sense. I need to back it up with actual evidence, which I'm working on. But once personal computers hit, and once you can get a computer for less than the cost of a car, it makes a lot more sense to just have a computer, because a computer can do everything, roughly everything, edge-notch cards can do, and not that much more expensively. And it can do more, because, if you buy an Apple II, since these, believe it or not, this is actually somewhat contemporary to the Apple II. If you buy one of those, you can have a database, you can play games, you can have a text editor, you can have pictures, kinda, not the same resolution or clarity, but you don't need to fiddle around with cardstock. Man, technology does not like these. So largely, my theory at least, is largely these die out as computers get cheap enough to just use anywhere. Oh man, I'm going to scan another one. But in that interim where they're actually in use, they're a really important, it's not really a missing link, but they're an important piece to the story of how people dealt with data. And I keep hammering on, these are all about indexing, which is something that we do in the modern day with databases or with the internet, with, digital high-tech computer stuff. But here it is on cardstock, vastly predating any of that. The other thing that's interesting about edge-notch cards, I could talk forever about these puppies, not very coherent, but it is information. These are actually, like I was mentioning, used in a lot of applications. So the boring ones are, or at least boring ones to me, sorry if you're an accountant or an insurance agent, are accounting, insurance, payroll, office stuff. I guess not payroll, since you don't do math with these. But in research, these were used really often as a bibliographic deck. So how those worked is, excuse me, I actually have examples hidden somewhere of Engelbart's bibliography decks. But they'd have like the abstract, author, year, the bibliographic information on the face of the card. And then on the notching, they'd have things like the year, the first and last initials of the author, a category, and most of the cards would also have a serial number. Oftentimes, they'd also have the starting letter of the paper name. What's useful and really interesting about that is, well, one, you can make a bibliography really easy. If you have all your sources on sortable cards, normally bibliographies have some kind of alphabetic sort to them if it's by first author or by article name or whatever. You got to sort it. You can do it with these. And you don't need to use a tabulator. Come on, do it. Do it. Anyway, so you don't need a tabulator to generate a bibliography. So you since you're not using resources and these are cheap, you can do more frivolous things with them. It's kind of like how when I was a kid, I know that I was taught to cherish each floppy drive or each floppy disk because my family didn't have a bunch of them. But now that I'm an adult, I have a whole pile of floppy disks. I break them all the time. They're so cheap and abundant, or relatively abundant, that you can mess around with it. You can do more day-to-day tasks. It kind of breaks down the barrier to doing more complicated and more experimental things. And bibliographies are a great example of that. I actually have seen a few examples of bibliographies. I think like 2 or 3 of the decks that I found are bibliography decks. It was a common practice, at least on cards. But what's interesting with the bibliography decks is you can sort. They each have a serial number, and that's important because on another deck, like let's say you have your bibliography deck, but you also have a deck of notes, and that might have abstracts. It might have just some little ideas that you're thinking of, or facts and figures. Well, you can write a reference number on the face of the card to the serial ID of the bibliography entry. So that way you can be like, oh, well, where did I get this idea about birds from? And then you just go, oh, well, it's a guide to birding, reference number 5893, and then go search that up in your bibliography, and you're like, oh, here's all the information on it. So you can do this like self-consistent internal linking, which hyperlinks. The other thing that people do, and once again, Engelbart's the one that I've studied the most. His decks had Dewey Decimal numbers on them on the bibliography cards, or because they're not Dewey, it's Stanford's Ascension numbers for papers and books. So that way, if you're looking through your bibliography and you're like, oh, well, I want to find the full text of this article, you just take the number and you go look on a shelf and it's there. So you can do this kind of external linking that's consistent with another system. So when you put this all together, you have a really robust package for data management. And it's really cheap and really simple since this is just cardstock. You can buy this stuff so cheap. Like, man, have you ever bought a ream of paper? It's way less expensive than a computer. And sure, you're buying the ones that are pre-cut and pre-printed and everything are a little more expensive, but the technology is really cheap. It's really accessible, and it helps break down, like I was saying, the barrier to experimentation, really. I'm trying to think about what else I want to talk about with edge notch cards, since I'm just sitting here scanning. So let's talk about this deck. This deck's weird. Most edge notch cards aren't like this. I think I already mentioned that, kind of. So usually, if you bought an edge notched card, they come blank. The edge would just be all holes. There's no notches. The face would be blank, usually with like a box and lines for writing. What's weird about these? So these come from a larger set. It's called Sort Guide to the Eastern Land Birds. And the idea is instead of buying a bird book, you buy this. It's like a super bird book, since there's no index. You don't need an index. The card is the index. So if you're out birding, you can grab one of these cards, identify some features of the bird, and then use this as a diagnostic tool to be like, oh yeah, it has this beak, this kind of head, these kind of ears, this coloration. Boom. It's that. Excuse me. So this is weird because this specific example is totally counter to everything I've been talking about. Sure, it has the same aspect where it's a cheap tool, you know, much like a lot of people I knew in college. It's a very cheap tool. But more importantly, this isn't for personal data storage. This is buying a package of information. But what I find interesting about that is, once again, the context. Because in Vannevar Bush's article, As We May Think, one thing that he mentions about the Mimics, why are you just getting that side, brah? One thing that he says about the Mimics is by storing information on microfilm and storing your link information on microfilm, it would be possible to share packs of data with friends or buy new packs of data to expand your library. So these would be something like a textbook and encyclopedia set. The example he uses constantly is an encyclopedia set on microfilm. But more viably, you could pass around link information with people. Now, this microfilm, this is not. This is cardstock. This isn't cellulite or cellulose, whatever. I don't know much about microfilm. It's not super important to my research. But this specific set, not Edge Notch cards in general, are a very close analog to what Vannevar Bush was describing, where, oh man, these are all the cards it didn't like to detect. To technology where you can buy a pack of information. The information's on there, and it has all this linking and searching information built into it. It's metadata, really. Come on. But so by buying this pack, you know, a birder might not know this many birds, but you don't have to. All you have to be able to do is identify features, and then using the indexing, you too can become a bird person. It goes back to Vannevar Bush, but this also meshes really well with, excuse me, with what Engelbart put forward, where it's dumb, it's cardstock, but it is augmenting human intellect, just in a form you wouldn't expect. And I think that's a really powerful technology. And it's one that there needs to be more scholarship on. And, you know, that's why I'm sitting at my desk on my day off work scanning these darn cards, is because someone has to do this. And I feel that way about a lot of computer history. There's, like I was saying, the history of computing is complicated. It's messy. The traditional narrative kind of sucks, right? Because, I mean, at least how I see the traditional narrative usually is, well, you know, computers started showing up around World War II's end. They were big. You got mainframes. The Manhattan Project happened somewhere along the line. And mainframes just do their thing. Eventually, the internet happens somewhere. One day, a personal computer appears. Varies from who says the story, but, you know, Apple makes a computer. IBM makes a computer, and then we all have personal computers. And then it just keeps getting smaller and faster and better. But it's not linear. The fact of the matter is, the whole history of computing, there's not that many ideas that are totally new. There's simple ideas like edge-notched cards, like punched cards, like As We May Think in the Memex, where someone finds a problem. In Vannevar Bush's case, it was, all these scientists that work under me, they spend too much time reading articles and finding sources. There has to be a better way. And then it gets fixed. But since a lot of the problems are universal, like how to manage data, that's a problem anyone with a lot of data has. And it's really easy to get a lot of data. So there's a whole lot of different takes on how to solve that problem. And edge-notch cards are one example of that is very underserved in the research. And none of these want to scan. Oh, man. Nope. Anyway, what I'm just trying to say is there's a lot of hidden technology in the history of the computer. And if you ever see these, let me know. I'm dying to find more of these. But then again, these are also really hard to find, pretty obscure. And eventually I'll publish a tranche of my research on these, but that's going to take a while because, one, none of these want to scan. They are incompatible with modern technology. But more seriously, there's a whole lot of work that goes into finding information about these. Like I was saying, finding guides are awful. Archives are weird and inconsistent. And especially with the coronavirus, everything's just a mess. I've been having a lot of long conversations with archivists about we might have some of those, but we're not allowed on site right now. So a lot of this is kind of in a holding pattern, which I got these a little bit ago. So this kind of ended up being the perfect time. Oh, that worked. To go back and scan all of these. Man, that did not work. Oh, man. Anyway, these scans aren't the best. I'll probably put them out online anyway. More of this is just... The reason I want to scan these is the same reason that I've been looking so hard for edge-notch cards, is because there's not that many around. Why aren't you auto-detecting now? Or at least there's not that many around that I can find. My conspiracy theories there are, but they're just hidden in archives that I'm not allowed to find. But because of that, every stack of cards that I get in is precious. And I have 2 physical stacks here, these, and then another stack of more traditional notes. And as you can see, these suckers are delicate. This is it's cardstock, so it doesn't warp as much as paper, but it's still, it's still pretty fragile. So hence, gloving up so I don't get my sweaty hands all over these, and hence digitizing these, because it's paper. It's gonna degrade, and the more you handle it, the worse that gets. So I'm very concerned with preserving this weird technology as much as possible. Come on, do the magic. And scanning it, digitizing it, researching it, and slowly writing a lot about it, I think is the best way I can do that. Because, like I keep saying, this is an important and little known part of our history. And I keep saying our history, and I don't mean American history. I don't mean the history of people who work with computers. I mean everyone's history. Computing has become such a big deal, and the internet especially has changed the world so much that we need to know where things come from. And in the case of edge-notched cards, this is where, or at least this is one of the places where a lot of the modern notions of data storage start to show up. And it's a playground. It's a... Maybe I'm not saying this the best way. Edge-notch cards, at least how I view them, they're kind of a playground for data storage ideas. Now, data storage might not be the most interesting topic, but it's really important. And anytime we can get this window into the development of something that's shaped the world, and especially when it's a window that people haven't cleaned up very often, then that's a place where we can do a lot of good. At least I think. So anyway, I think that's the end of the stream for right now. I have these last two cards that don't want to digitize, and man, I need some lunch. So I'll go offline. Hope to publish this. I don't know if I recorded it. I don't know how to stream. For someone who works with computers, I'm not good with computers. But I might be back online later today or maybe this weekend to do some more scans. Until next time, if you want to learn more about the history of computing, check out adventofcomputing.com and my podcast, Advent of Computing. It's basically everywhere. I can't think of any site for podcasts that doesn't have on it or have it on it. Anyway, have a great rest of y'all's day.